Welcome to this webinar. My name is Sven Goldstein and I'm Product Manager TwinCAT, especially for connectivity. And in this webinar, me and my colleague Daymon Thompson, Product Manager TwinCAT North America, will tell you and show you how easy it is to solve industrial interoperability scenarios based on TwinCAT tools for various use cases. There are options for you to submit any questions that you may have, and we will collect and answer them after today's presentation. In GoToWebinar, please use the dialog area on the right side to submit your questions. As an alternative, you can also submit your questions in an email to meet@beckhoff.com. At Beckhoff Automation, we believe in offering an open platform with many connectivity options for connecting your automation application with other devices all the way to the ERP system and the cloud. And this is why we now offer more than 30 communication protocols in our product portfolio, and we continue to implement additional communication protocols because we think that the automation world constantly evolves. And this is, for example, why we have just implemented, for example, an HTTPS client to allow our customers to access RESTful web services from within their PLC application. This philosophy of having an open platform, of course, extends to our software products. Being able to easily utilize our TwinCAT software products in conjunction with various industrial devices is an example of a truly powerful and open architecture. Perhaps the most vendor-neutral communication method is via OPC UA. OPC UA gives a common protocol for industrial devices to exchange information from sensor to cloud and has been deeply integrated into our Beckhoff products. Like I said, OPC UA is another important communication technology, which we offer in different products and which we will introduce later on. During the last few years, OPC UA has seen a very high adoption rate across different industries, and it can be seen as the standard that enables industrial interoperability with integrated security mechanisms and possibilities for information modeling across all layers of industrial connectivity, ranging from sensor and PLC devices up to the ERP system and the cloud. But let's have a look first at our common history with OPC UA as a technology and the OPC Foundation in general. Everything started in the year 1998, in which Beckhoff became a member of the OPC Foundation and also had its first OPC-related product. Back in the days, this was the COM-based OPC DA standard, and the related Beckhoff product was called the TwinCAT OPC DA Server. A few years later, in 2006, OPC UA was introduced as a technology, and the first version of the OPC UA specification was released. In the same year, Beckhoff has announced and prototyped a corresponding OPC UA server product, which enabled access to variables from the TwinCAT real-time via OPC UA. Since then, Beckhoff has pushed and promoted OPC UA as a technology and worked together with the OPC Foundation and other vendors to further enhance this standard. And since 2010, Beckhoff employees have a very active part inside of the OPC Foundation. For example, a Beckhoff employee got elected as the president for OPC Europe and later became also global president of the OPC Foundation. At the same time, multiple Beckhoff employees have joined different OPC working groups to collaborate with other vendors, for example, to create companion specifications for the different industry branches. Before I now pass to my colleague Daymon, let me give you an overview about the different layers in which we have implemented OPC UA into our products. Let's have a look at the automation level in which our controllers perform their duties. Every Beckhoff controller is equipped with a free-of-charge OPC UA server called the IPC Diagnostics OPC UA server. And this server enables customers to read hardware and software information from the industry PC. For example, CPU temperature, mainboard temperature, fan speed, smart information from the hard disk, and much more. In addition, we also have our TwinCAT OPC UA client and server applications running directly on the controller, and those applications offer access to or from the TwinCAT real-time. Because of the internal communication architecture of TwinCAT, these applications can also be installed and operated on an edge device, for example, to retrofit machines. So, for example, you can take one of our C6000 industrial PC series, install our OPC UA products on there, and then, of course, access other devices via the network. With our TwinCAT HMI system, we have an HTML5-based visualization, which also comes with an integrated OPC UA client that is able to access remote OPC UA servers to display and visualize their data. At the same time, we have our TwinCAT Scope, which is a powerful charting tool for diagnostics, which also comes with an integrated OPC UA client. A few years ago, we have introduced on the field level a device which is called the EK9160, the IoT coupler, which comes with an integrated OPC UA server that offers easy and secure access to I/O data points. So for example, you only have to attach the I/O terminals, you boot the device, and you will immediately see the I/O terminal on the OPC UA server address space in order to access its information. At the same time, we also have products available that allow you to communicate with the cloud, for example, via OPC UA PubSub. And at this point, I would like to hand this presentation over to my colleague, Daymon Thompson. Daymon will show you how easy it is to configure various TwinCAT software products and tools for communications via OPC UA. For this webinar, we have chosen to use a Rockwell controller as the third-party controller. Daymon, please take over.
Hello, and thank you, Sven. That's correct. Today we're going to set up a Rockwell controller to talk to OPC UA and then connect that to kind of a suite of Beckhoff software tools. Embedding OPC UA into various TwinCAT software tools means these tools can be utilized with existing control systems, devices that perhaps you can't change out the controller, but you want to change out the HMI, or you'd like to use some analytics and diagnostics tools. Or it's for OEMs that are kind of in the conversion process of transferring from a previous generation machine or from a previous architecture using someone else's controllers to a complete TwinCAT and Beckhoff control system. And so it's the same kind of idea. You're utilizing OPC UA, we can use the TwinCAT HMI with another third-party device or controller as we're transitioning, or we can use a myriad of different connectivity options, connecting it to cloud or connecting it to analytics. And we'll go through some of those as we go through this webinar. As Sven mentioned, OPC makes really a perfect vendor agnostic communication channel between devices and software services, really eliminating the need to manage all of these multiple different proprietary protocols from every single hardware controls vendor. Many modern industrial devices just really come enabled with OPC. Sometimes it's just enabling it in software, but the device is capable of having OPC directly on board. Some of our industry friends, competitors' devices, they don't have the capability of running an OPC UA client or server directly on the device. And so in these cases, it requires adding either a separate piece of hardware or a second PC or gateway device with an OPC UA kind of gateway to translate between the proprietary protocol to talk to that older hardware or to OPC UA as an OPC UA server. Some older machines and equipment, we also offer a device that will go directly from sensor to cloud, we call it. So directly from analog or digital inputs and turn that directly into OPC UA with no programming, just a web-based configuration page. So another option for adding OPC UA to existing machines. In our demo today, we're going to use this Rockwell controller, like I mentioned, in a very simple PLC ladder logic program. And it's very simple. And the reason that we're doing the very simple is not to focus on the application code or how in-depth the application code is, but really on the tools around it and the connectivity and the interoperability of the tools. So we kept the application code very simple so we don't kind of muddy the water. So our first objective, as we can see on the screen here, our first objective that we'd like to accomplish is say, well, we have this existing controller. In our case, it's a Rockwell controller, but it absolutely could be any device, industrial device or controller that speaks OPC UA. So we want to have it connect to TwinCAT HMI. So we need to first get OPC enabled. So in that case, we wanted to bridge something in the middle here that's going to take the proprietary protocol and convert it into this vendor agnostic, very industry friendly protocol of OPC UA. Before we dive into that, let's take a look at what our simple ladder logic program actually looks like so we know what kind of bits and bytes we're dealing with as we walk through this exercise. So here we are inside the ladder logic Rockwell program. We can see that as I start toggling some bits here, we have a start and a stop latch circuit. So basically the hello world of ladder logic, right? So as we start we hit the start bit, the counting coil turns on. Once that counting coil is on, then we have an adder that just continually every cycle adds. So basically just a counter. And we turn that guy off and he stops counting. So pretty basic, pretty straightforward. Like I said, not really wanting to get too deep with application code, but focus on the tool set. But this is kind of what we're going to be working with, is this very simple ladder. Okay, so now we need to take this first step. And that first step is enabling this device to speak OPC UA, be an OPC UA server in this case. And in this case, we're going to use the RS Links gateway to accomplish this. There are several software out there that will go from the proprietary hardware into OPC UA. As I mentioned, some devices, it's just enabling it in the current industrial device, and then we have an OPC UA server built in. In this case, with the RS Links gateway software, we're going to run that on the same device, the same panel PC that we're running TwinCAT HMI. So no additional hardware needed. We just install that other piece of software right along next to the HMI. Okay, so let's take a look at how that gets set up, and we'll kind of run through these steps quickly just to show you that the steps of going through the factory talk side. All right, so here we are in the factory talk administration console. So we basically add a new application, and we'd like to do an OPC application here, add a new area, give it a name. So in this case, we're using a SoftLogix. We would like to add a link server properties. So there's some naming that happens in there. Some communication setup needs to happen. And all of this is documented, obviously, inside the Rockwell's product documentation that goes over all of the different unique settings here. So we're looking at this SoftLogix VM, and we see, yep, I see all these different devices. Now we're actually in the Links gateway configuration. And we say, okay, well, I want to do a new configuration. We give this kind of a name, and then we add a URL so we know how to address this OPC UA server. There's some other options here for certificates, other settings. Those can be set up, depending on your application. And again, all documented on the Rockwell side. We just wanted to quickly show you, yep, we're just walking through the easy steps of getting this configured to be an OPC UA server that we can use for our next step. Okay, so as we can see here, we've done an OPC UA server, and that's now enabled. And now we need to connect it into TwinCAT HMI. So TwinCAT HMI in this case will be an OPC UA client. And let's, in our next steps, take a look at what that looks like to configure that inside of TwinCAT HMI. Okay, so here we are back in TwinCAT. So we will open up our references. And in references, we use sort of like libraries. We add to the HMI, but these are built on NuGet packages. We grab the OPC UA package and add it to our HMI project. And we see that it adds it into our HMI server extensions. So it adds it in and says, yes, we're enabling the server to run as an OPC UA client. And you see the little green arrow next to it, to the OPC UA client. It says, yep, great, everything's been added, it's up and running, I'm ready for the next steps. So now we say, well, next steps are going to be, I need to point it at where the OPC UA server is going to be, right? I got to tell it where to communicate. So in the properties of our HMI server OPC client, we just put in the URL here. I'll just copy and paste that in. And now we can connect directly to the OPC UA server. So here I'll drop in a button. Let's see. We need to bind that button to an OPC tag. So here we're just browsing the server and saying, hey, OPC server, which variables are available to me? We say online, we see it's a factory talk. And in this case, I'm going to choose the start bit. So we remember that from the ladder logic application. We'll rename this button to start, and we'll just toggle that bit back and forth. And we'll add a second button here. I'm going to walk through the same steps. So with that button, we'll link that guy, create a data binding. And again, browsing that OPC UA server, I can pick, yes, I want the start bit that's being published from the Rockwell device. And next step, we'll drop in a text block. And this text block will say, we want to see the current counting value of that counter that we saw from our ladder logic program. So same thing, we'll create a data binding and say this box is always going to update when there's new data on the OPC UA client. We pick it here, and now that device or that control on the HMI has been linked to that property being published by the OPC server on the Rockwell side. Let's take a preview of this. So here we see the two buttons. We hit stop, start, and we can see the actual value of our counter, and we're interacting back and forth with the ladder program. So really straightforward, super fast, and really easy to do. Okay, so we have our HMI communicating, great. Let's go back to our architecture view and say, okay, I now have this communications between this OPC server all the way up to the HMI. Now we say, well, what else can we do now that we have this enabled? What other TwinCAT Beckhoff software products can I leverage now that we have OPC UA server on this machine? Well, the first one we'll take a look at is the OPC UA server to our scope view. Our scope view tool is extremely powerful. And maybe before we go into the connectivity portion, let's take a look at, what is scope, what is TwinCAT measurement. So TwinCAT Scope is, as I mentioned, a set of tools for visually and graphically seeing the data within the control system. So within the TwinCAT runtime environment, we can see things from the NC, the motion controller, things from CNC, from the PLC, from field buses like EtherCAT or Ethernet IP, directly inside of a charting tool. And those things can be correlated to what was the motion controller's position when I gave the position out via EIP to some sort of device. I can correlate these and say, okay, what was the timing difference between those two commands, for example? And for that, we would use like a Y versus T or a Y versus time chart, as we see in the upper left-hand corner here. And there's various different charts for different applications. So I gave you one for the Y versus T. Another one just below it is the array bar chart. This might be used if you're collecting data in an array. Could be used if you're doing XFC oversampling on EtherCAT, meaning you're taking samples every 10 microseconds. Maybe you're pulling back each PLC scan, 100 or 1,000 samples per scan. This data could come back in a bar chart and you could see what happened during the middle of that scan. So bar chart would be perfect for that application. Digital display, if you wanted to show the actual voltage in this example, next to what the trend of that voltage was in a Y versus time, but actually show the actual time next to it. Though the X versus Y chart or XY chart, also a really great chart for things like in CI, G-code, coordinated motion. You can really see the G-code processing between those two axes. A single bar chart, same idea with basically bar charts with one variable that moves back and forth within a range. Then you can see how that variable is changing. The other one I wanted to add was a new feature. So being really system integrated approach is really what system or TwinCAT's all about. We also have a new product that is called TwinCAT Vision that is used for traditional vision application to industry, such as barcode reading, inspection, finding features for location. But again, because it's all integrated into one system, we can take that same image and instead of using it for inspection or barcode reading, we can use it for observation. And as the images come into the TwinCAT real-time system, they're time-stamped and can be very closely correlated to the actual data timestamps as well. So here we see scope, and we've kind of overlaid or underlaid the image coming in from a camera that's seeing what exactly is happening on the machine. And what we can see is the green line is the vacuum cup, is the actual a suction on the vacuum cup. And we can correlate these things and say, well, maybe there's something anomaly happening. And while I look at just the vacuum data, I don't understand why. There's a little dip, there's some variation, but I don't know why. And so, I'd really have to watch the machine, look at the chart, try to think about what was happening in the mechanics. Overlaying these, I can see that as I walk through on the time frame, I'm also walking through the images behind. And so now I can say, like here, as I get to this little dip, I can say, well, what was happening right there mechanically? Oh, that looks like no big deal, actually. It's just when I turned on the vacuum before I went down to pick up the brick. So correlating those things helps make decisions very quickly, helps find issues very quickly. So that's just another option within the TwinCAT scoping tool and overall TwinCAT measurement suite. Okay, so now we want to take that scope view and we want to read data directly from this OPC server. We want to read data directly from that ladder logic program that we looked at earlier. So let's dive into what steps look like to enable that. Okay, so in TwinCAT, the first thing we want to do is add our target browser. And this target browser allows us to view data from ADS, directly from TwinCAT, from a database, from TwinCAT Analytics. In this case, we have an OPC UA tab, and we add that OPC UA server, and now I can browse all of the objects that are available in that server. So here we see the factory talks link gateway. I'm kind of traversing through this tree down to the online variables, and I can see I get several online variables. Right click and say, hey, I would like to add that to a project. And here we say, what kind of project? Well, a Y versus time, that makes sense. And we're adding the project to our existing HMI project. So everything in one solution. And we can continue to browse and say, I want to add the counting, I want to add the start, I want to add the stop. And I can preview this data, holding down the space bar to say, yeah, I am getting live data here. Okay. So now we hit start on the scoping. I can see the green line is the actual count growing up. And then the purple shading, or the bluish shading, is that 0 to 1 scale. That is my counting bit. So whether I should start or count or not count. And so we can see that during the shading bit, I count. And when that turns off, it stops counting. And I get a flat line on the count green line. So pretty basic. Interacting with the OPC server from HMI on the right-hand side of the window, and seeing that data be fed back into this live scoping tool, kind of on the right hand or kind of in the middle of this window. And we can see how easy that was to configure as well. A handful of clicks, browsing tags, add them in, hit record, and that's all there is to it. So let's take a look at these really next to each other. So here we have TwinCAT on the left, so that same scoping chart we just looked at. And instead of interacting with it via the HMI, we'll interact with it directly in Studio 5000. So we see the same results as bits are toggling inside of the Studio 5000 PC, or in the controller. We see that the bits reflected in our scoping tool. Okay, so back to the architecture. So we've added that OPC UA server. With just a few clicks, we added the TwinCAT HMI to communicate, so we could use TwinCAT HMI with this controller. We've utilized the scope view for doing diagnostics, machine optimization, some troubleshooting, a really powerful tool, and we saw how easy that was to configure as well. And now maybe the next portion of our project here is we say, well, we would like to connect from one machine running this OPC UA-enabled device to a second machine. And in this case, maybe this is a TwinCAT running machine. So we could connect machine 1 to machine 2 using Ethernet IP, sure. TwinCAT can be an Ethernet IP device or an Ethernet IP scanner. So we could be either one. But this is really an Ethernet IP webinar, so we'd like to connect to this via OPC UA. We can do this directly to the different controller because TwinCAT can act as an OPC UA server or an OPC UA client. In fact, there's two different ways it can act as a client. One is through the PLC open function blocks for OPC clients. The second way is just adding an OPC UA device underneath the I/O tree and configuring it like you would on a second device or another field bus. That's actually the method we're going to use today. And in this example, we're going to use the server client architecture from OPC UA. But in the very near future, TwinCAT's also going to support the OPC UA pub/spub specification for controller-to-controller communications. So stay tuned for more product announcements and future webinars specifically on that functionality. So in this case, we're going to set up this controller-to-controller using OPC UA client server, and the TwinCAT side, machine number 2 in our little example here, is going to be the OPC UA client. Okay, so back in TwinCAT, we see we have our HMI on the right-hand side, our scoping tool on the left-hand side. And now let's add a new project. So we're going to right-click, new project, and this is just going to be a base TwinCAT project. So we're adding it in. Now we're going to right-click on devices here and say we want to add not an EtherCAT device, maybe not a TCP device, but a OPC UA device. And so we see that it adds it in, and just looking through some of the options here, we see how fast do I want to drive this via a real-time task, how fast do I want to update. And I'll right-click on this guy and say I want to add a new item underneath that. Well, what is it? A client. I want to add an OPC UA client. adds it to the tree. And now we need to add a few parameters. So one of those being, where's the OPC server I'm going to be looking at? So I just copy and paste that URL in here. Now down here under the data type names, I can give variables new naming. There's a diagnostics tab. But what I really want to do is just right click and hit scan. And scan's going to go out and ask the server, or the OPC server, what tags or what nodes, objects are available. And so I browse through here again. We see that here's all of my start stop bits, and we add those to the IO tree. We kind of look through those. So yes, we get values. We're going to be reading those. Some of these will enable here in a moment to write. We can see that if we just click on them right away, that in the middle window, we get live values. Now we're going to add a PLC. So we have our OPC data. We want to put it somewhere. So we're going to add a PLC. So we right click, add a new PLC. And in this main structured text POU, let's declare a few variables where we want these OPC variables to end up. So we'll just say, hey, I have a start variable in the PLC, and that's going to come in from outside the PLC. I'm going to link it, and maybe here's a stop bit. Maybe here's a counter. And we link the PLC down to the OPC. And the way we do the linking mechanism, not just do it directly in the PLC in this case, is we could use this virtual device to link some of the OPC data to the PLC, some directly to a MATLAB Simulink object, some to a C++ object. We can link it with different places within the real time. So we compile the PLC, and it gives us these input and outputs underneath the instance. And so now I can just right click those, and as I mentioned with the linking, say, okay, that PLC variable, that's going to be this OPC UA tag. Great. So we pick that, and it links, and we can continue down through most of the other variables that we're reading in via OPC. Now we need to check a box here that says, yes, I would like these to be enabled for write, so that the PLC can write back to the Rockwell PLC, because we'd really like our start and stop bits to control the other device or set bits on the other controller. And so here we're linking those output variables as well, and a variable that says, yes, it's okay to write to those. Okay, so now we activate this configuration. So take all of our configuration and kick off the TwinCAT real-time running. So now we're up and running. And we see the value immediately in this count window. We see immediately the counter read in from the Rockwell ladder. And if we interact with the start and stop bits, we can see our counter starts, our counter stops. So really just showing interaction between the two different PLCs. Again, that was all the clicks. That was the entire setup. So it's pretty straightforward, pretty easy to configure all those things within the TwinCAT tools. Okay, great. So now we have our HMI, we have our scope. We're talking between the existing controller in the Rockwell side to our TwinCAT running machine, which may be sitting next to it via OPC client server. And so, what else might be helpful on this machine? What other functionality can we enable? Well, one is, what about being able to do remote analytics or look at the data live to do remote maintenance or remote troubleshooting via the cloud or via your internal infrastructure using MQTT. So in this case, what we're going to do is add this IoT data agent here on this running on the same HMI PC that's going to take this OPC data and turn it into an MQTT stream. And that MQTT stream will go through a Mosquito broker, and we'll set up on the other side the analytics workbench or also the analytics service tool to quickly analyze some of the data and kind of see what's going on, as well as maybe we want to see this more long term. But the data agent can not only just send it to a Mosquito broker, we can also send it to a multitude of different cloud-based options, things like AWS, Microsoft Azure, Bosch IoT Suite, IBM Watson, pretty much any software, whether it be a local in an enterprise like an ERP system, or cloud-based that supports MQTT and JSON, can be talked to or be data read and written directly from the IoT data agent. So it really enables this third-party controller to be cloud or IoT enabled. And we'll take a look at that simple configuration actually. So inside the data agent, this is a screenshot here, we see that we just add simply these different locations and what we call them gates. So we say we want to read or write data to maybe TwinCAT Analytics, or maybe this is generic MQTT JSON location. We want to talk to a broker. Or here, maybe we have an AWS IoT core. We just right click, add that in. Or Microsoft Azure IoT Hub, or OPC device we want to read in, or directly from TwinCAT PLCs. Even if it's a TwinCAT 2 PLC that's been running in production for 20 years and we'd like to IoT enable it, great, we can add an edge device running the IoT gateway, or the IoT data agent acting as a gateway, and read that data via ADS and send that data to the higher level system, cloud-based systems, any IoT software. Okay, so back to our scenario here. Let's take a look at what that would take to set up. So from the IoT data agent through this broker that's going to be running on the cloud, back to this TwinCAT Analytics suite. All right, so here we are in the data agent, and I would right click and say we want to read data from an OPC UA device. So first we want to add a gate that's an OPC UA gate to our project, and that's this big circle here. And then we need to say, well, maybe we need to give it a URL. What OPC server am I talking to? So here I need to change this to, let's see if I can get it. Change this to where our Rockwell OPC server is, the factory talk links gateway. There we go. I'll just paste it in. Maybe we change the name of the device. Maybe that needs to be something more readable. Let's see, a little adjustment here. We'll call this one Factory Talk Links Gateway. There we go. All right. Now that we have our OPC gateway, we want to say, do I want to subscribe or publish data to this server? Well, in this case, I'd like to subscribe to data. I'd like to read data from this from the Rockwell device and send it to our analytics. So I'll add in this subscriber. We have various properties for how fast do I want to read, etc. I can right click here and add my own symbol, but really I'm going to use the target browser again, and I'm going to drag and drop. And here I get a message that says, hey, looks like you didn't put in your URL quite right for your OPC server. Would you like us to adjust it? Yes, I would. Great, thanks. Now we have this variable. Looks good. And again, we just drag and drop it up from the target browser where we're just browsing all the tags available on this OPC server. And I'd like to add some more. So I grab all these, drag them up here, and it adds them to the list of things that we're going to be subscribing. Okay, looks good. Maybe we rename this a little bit to, these are the things we're reading in from the Rockwell device. So maybe we'll just make that clear and say, these are the ins to our communications gateway here. And then I'll right click and say, but I want to send this data via MQTT. So I just add an MQTT gate and we get this nice little icon of a cloud. And maybe we rename this. In this case, we'll use a broker that's writing on TwinCAT Cloud Engineering. So we call it TCCE. We can give it a client ID. Here we need to say, where is the MQTT broker located? So we can put that in. And then there's obviously various authentication can be used, security certificates for encryption, all sorts of different mechanisms. Today we're going to keep it quick and simple. So now we say, well, what do we want to do to this broker? We want to publish data to it. And so I right click and add this publisher. And there's all sorts of options about, what would I like to send for a cycle time, how fast. This one's the important one, where I like to send it as raw binary, as JSON, as TwinCAT JSON, or as TwinCAT Analytics binary stream, so that we can send it nice and compressed, and we can read it into our analytics suite. Okay, so now that we have the publisher here, we can, maybe we make this consistent because we're good programmers. We're going to say that's the data from our gateway here that's going to go out. So we'll call them outputs. All right. So now we say, well, I have the broker set up. I need to link these guys. So I can just drag and drop from the inputs to the output side here. And it actually automatically creates the symbols on the MQTT side and links those two. So now anytime that there's new data that comes in via OPC UA, it'll automatically translate that over to MQTT in that TwinCAT binary format. So we go up here and say, okay, cool, run this configuration. We see it goes into run mode and it's active, translating the data, acting as a nice gateway. Okay, pretty straightforward. Very easy to set up. So now we have the data agent here, which is grabbing this data and converting it into this MQTT. We're sending it to our broker living in the cloud. Now let's take a look at, from a remote workstation, we can use the TwinCAT Analytics Suite to see what kind of insights can we find from that data. So again, we're using a very simple ladder project, but we'll go through some of the tool sets. All right, so back in TwinCAT, we'll say the first thing we want to do here is add a new project. And it's going to be an analytics project. So we'll give it a name. Maybe it's the links analytics. Create a new project. Looks good. So we have an analytics project. We'll bring our target browser back in here. And in this case, instead of doing OPC UA, we want to use this TwinCAT Analytics tab because now we're sending it via MQTT through the cloud. Again, we need to tell it, well, where's the MQTT broker at? Great, that's our location. Check the connection, looks good. So now I can browse and say, oh, it looks like there's multiple machines actually that are sending data to this guy. The first one here we see is named FactoryTalks Link Demo. So it's the one that we're interested in. I can bring up this machine administration page and say, that's great. I would like to give it an alias though, better than a system ID, so that's more human readable about which device is which. So we'll give it a quick name here. We'll call it the alias device is going to be FactoryTalks Link OPC device 1. And we'll give it a location. Where is this located? Well, it's located near me here in Denver, Colorado. Okay, so now we have this device. We can kind of browse again and see these tags that we've been using through the demo. Again, we can hold the space bar down and say, yes, that's the variable I want. I'm getting live data. It's kind of a data preview. So now we have set up where we can grab that data from the MQTT broker. So now we can drag in tools from our toolbox. And maybe what we say is, yeah, hey, I want to look and see every time the start and stop bit are turned on or turned off. I want to capture that. And I want to know how many times they were turned off, when they were turned on, when they were turned off, etc. So I can drag those tools in. Here we're going to grab a moving average that says, hey, I want a moving average of this counter. And I drag and drop from the target browser into the input of these tools. And then as we see when we run these guys, we'll see that they're automatically bringing in, giving us other data out of it as it runs through these analytics tools. This is obviously a very easy example, simple example, but there's over 60 tools in the toolbox for doing things like signal analysis, fast Fourier transformations, all sorts of more complex tools to be able to optimize machines, look for preventative maintenance, all sorts of different use cases. So here we see we're receiving data in, and each time I actuate on the Rockwell side, we see that we get an event. And that's great, but really I'd like to visualize this data. So we add a reference scope here, and now we see the data that we're running through our analytics tools, the count and the Boolean. And that's nice, like we've seen before, except now we're doing it remotely, maybe sitting in an airport. And we're running it through additional tools. So now that I know that the Boolean is high or low, I know how many times. And I would like to know when was the last event. So maybe I'm looking at historical data here and I say, well, when was the last time this occurred? So using these analytics tools and getting events, I can actually mark this graph with the derived data. So in an average, or in the case of a FFT, maybe it's the frequency domain, maybe it's just a timestamp. So let's take some of these. So we'll say the moving average, I'll add to my graph. Maybe I would also like to add the moving minimum to my graph. Maybe the timestamp for one of these Booleans. It says, hey, when exactly did that happen? And you say I can correlate between the two different graphs. When that Boolean went low or went high, this is what was happening on my average. So I can correlate things. You know, what was the motor speed at when that alarm triggered? And what was the motor speed at when I loaded that? So now I hit record again, and I can see that not only am I scoping my actual data coming from the controller, I'm also scoping the derived data as it's calculated through these different analytics tools. Okay. So now we have our tool set up. Let's next say, well, maybe I don't want to just see that for diagnosis one time or troubleshooting one time. I'd like to have these things monitored all the time. I'd like to know when this happens. I'd like to pull up a dashboard on this machine and see exactly when my start and stop bit, and how many times they were actuated, and what my current average is. So for each one of these tools in the toolbox, I'm choosing on the right-hand side here a HMI control to visualize this data. There's at least one control available for every tool in the toolbox, and sometimes there's multiple. Now I'm going to deploy it and say, great, I want to take this project and I want to say, well, where do I want to run this 24/7 monitoring? On the PLC, on a server or device? Do I want to stream the results back to the broker? Do I want to create a TwinCAT HMI? Yes. Do I want to dock on the left? Do I want to dock on the right? Do I want big spacing, little spacing? Do I want the distance between the controls? Maybe different languages. We'll add maybe another language here. Then we say, okay, what version of Visual Studio would I like to build it in? Or TwinCAT XAE shell, and it gives a summary. So what it's going to do is, for all the tools that I've used in this network that we've built up in this workbench, it's going to generate an application that will automatically deploy and that'll watch for these things 24/7 and create a dashboard using TwinCAT HMI, so web-based HTML5 technology dashboard, that we can see what's going on. So again, I can pull up that dashboard and see, what's the average time the machine's been on and off, and how many times in our application, our very complex ladder program here, how many times have these bits been turned on and off, and what's the average of the counter. So we see in the background, we're automatically generating an entire TwinCAT project. We're automatically adding in the HMI. We're linking the HMI to the TwinCAT project. We're really building this out, the analytics tools, in the environment that you know already, which is just native TwinCAT tools. Okay, so we built it out. Let's open this in Chrome and see what our dashboard looks like. So we fire it up. So there's our marker there in Denver. That's our machine location that we added in. Now we'll look at this network we built up, and we see, sure enough, there's our 3 tools that we graphically drag and drop in our workbench. And we see each time that edge goes true, the edge goes false. On the right-hand side, this is the little object I used to visualize that averaging. So we see the average. Now I want to clean this up a bit. So we're going to change the name. Maybe we need to make some modifications. Network isn't great, so I'm going to call it FT OPC machine. I'd also like to see the live data. So let's dig through here and find these tools, just a trend line, and add it into our project. There we go. So we drag and drop it into our project, and we say, well, okay, great. Which variable would I like to use? There's several ways of choosing inputs here. So I could have virtual mapping, so I could pull these from different devices, different sources that the data can come from. So maybe it's different locations. In this case, I'm just going to keep it simple and just drag and drop this from the target browser again. So I grab the counter and say, yeah, I'd like to use that one for this graph. Yep. Maybe rename the graph title. Maybe that channel doesn't make a whole lot of sense. We'll call it something like counter value. No, current counter value. That makes sense. Okay, then now that I've modified this project in the workbench, you hit save, and really we just run through that same deployment process again. TwinCAT will update the TwinCAT Analytics deployment will update the TwinCAT project in the background that we saw that was generated, and it'll update our dashboard, and we'll have all these modifications shown immediately on the dashboard without any programming, just one-click dashboard, one-click generation of this analytics runtime. That's great. All right. So now let's take a look at some of these things together. So here's our updated dashboard in the upper left-hand corner with our new FT OPC machine instead of network, our graph on the right-hand side. On the right window, we see the mobile view of that same HMI. So we didn't have to program anything. It automatically generated this HMI with some different mobile views here. And then we see on the bottom left-hand side, the actual PLC program. So as we're interacting with the Rockwell ladder, turning the bits on, turning the bits off, as the machine would normally run, we see that reflected up here on our analytics dashboard. We see that also reflected over here on our mobile device for the average values. Again, our application here, super simple. We didn't want to get lost in the details of the application code. We wanted to look at the tool set, but you can really extrapolate this out, how we can use the TwinCAT analytics tools with third-party controllers to do things like overall equipment efficiency, see how many times it's been turned on, how many times have we run this product today, are we on schedule, are there any maintenance tasks, etc. And again, our dashboard, not the most complicated looking dashboard. I wanted to just throw a few other examples here of some of our customers or things that we use actually ourselves internally for multiple machines spread across the world, and having those pins for location give actual machine status, whether they're running, or they're down, they have a problem. Some things at the bottom, you can see, how many are we on track for the early shift, the late shift, night shift? Are they producing enough? What's the current shift production? Are we behind? Those kind of dashboards are easily created in this one-click dashboard TwinCAT Analytics Workbench as well. And speaking of using this tool internally ourselves, I wanted to give another example of a little more complex than a latching sequence in a ladder program. What we're looking at here is an application where we're using many tools, and actually many tools across many different networks, and even some of those networks cascaded. The tool outputs going into other algorithm inputs. And what we're doing, as we see on the map, as we zoom in, is we're monitoring power usage or energy monitoring within a couple of our different production buildings. But we say, all right, building F and building T. And so each one of those now has its own set of pages and tools. So we open up building T, for example, and we see, yes, there's some histograms, we see live data. We also see this little stanky energy monitoring graph down below, where we can say, hey, out of 100%, these are where the different percentages are going. Here, where you're measuring the efficiency, the total efficiency of power. Other things here, of course, just an application example, but how much is the cost currently in euros? How much energy consumption? We can see on the left-hand side the distribution of the actor power. So just giving you an idea of a more built-out, full use case dashboard. Okay, so let's do a little summary. So we took an existing controller, in our case it was a Rockwell controller, enabled it to be an OPC UA server. We connected that to TwinCAT HMI with our start, stop, and counter buttons. We then could graphically view that data, so those bits, anything kind of exposed over the OPC UA server inside of our TwinCAT scope view. Then we set up the data agent with just a few clicks, drag and drop, so that we could use that data and send it to the cloud. We sent that through a Mosquito message broker living on the cloud via MQTT to TwinCAT Analytics Workbench running on my engineering laptop remotely. And I set up the engineering workbench for some very simple analytics, which we could view locally, kind of in a service case. So I'm troubleshooting or trying to optimize the machine. And then we took those tools and said, yes, I'd like to deploy those as a 24/7 monitoring the machine, collecting data, and generated a dashboard. And so we did that, we deployed it, and we saw that dashboard running within a browser and on a mobile device while we were interacting with the Rockwell controller. So really bringing all of this together here in just a few minutes and a handful of clicks. Very easy software to configure and use. And with that, I'll say thank you for joining me on the walkthrough, sticking through with me. And thank you for letting me show you the interoperability between all of the different TwinCAT tools and the very powerful Beckhoff software tools. And at this point, I would like to hand it back to Sven. Maybe, Sven, you have some closing words for us.
Thank you, Daymon, for showing us how easy it is to connect our TwinCAT toolchain with third-party devices like the Rockwell controller that you have used during your demo. We have seen that Beckhoff offers deep OPC knowledge and experience with OPC-related products since 1998. Our products and tools allow our customers to solve many different use cases, ranging from classic M2M connectivity up to connectivity with the cloud. And the openness of our products and the technologies behind give our customers the flexibility to utilize such software tools with third-party devices. During this webinar, we have only covered a very small portion of what TwinCAT is really capable of. And while Beckhoff offers outstanding interoperability with nearly all industrial devices through open software and support for more than 30 different communication protocols, we have a very powerful automation system and also hardware offerings, including our XTS, XPlanar motion solutions, our scalable industrial PCs, which you can get from very small ARM devices up to very powerful many-core CPUs, and of course our I/O components, the I/O terminals and all the different sensors that you want to attach to our automation system. And at this point, I would like to thank all of you for joining us for this webinar. And I hope that we have given you some new ideas on industrial interoperability. And last but not least, I wish you a wonderful week. Stay safe out there and hopefully see you soon. Bye-bye.